All right, welcome back. So today we're going to do advanced memory potential and electromotive force questions. So all these questions you're about to see are something you would see on a midterm or an exam. How do I know this? Is because these questions are exactly on my midterm and exam. So let's get started. Let's do this. We have an alien that's arrived on Earth. He decided to kidnap the poor creature to understand marine physiology. The alien has ions A, B, and C with the resting memory potential of negative 80 millivolts. Answer the following questions given in the table. So we're given that ion A equals reversal potential at positive 40 millivolts, or reversal potential is, where the ion feels comfortable at, right? And wants to stay at. B, reversal potential is negative 80 millivolts, and ion C, negative 100 millivolts. Which ion has the greatest electromotive force? Don't guess. Use the electromotive force equation and show your work. Circle the correct answer. Okay, so you don't even have to use the equation. You can literally just look at it and I can tell you what the correct answer is. Which has the highest force, right? The way you know is you look at the resting membrane potential, which is negative 80, and you're going to look at this table and you're going to see which number is furthest away from negative 80, right? Which number is furthest? That's obviously positive 40. Okay, negative 80, right? That's the same number. And C is not as far as positive 40, right? Negative 100 is only 20 away, right, from negative 80, where positive 40 is 120. So the correct answer is A, but of course it says use the equation, so we're going to do that. The equation goes as follows. Force equals resting membrane potential minus E ion. Okay, so let's do B first. Force equals the resting membrane potential, which was given to us, negative 40, minus E ion. So B is negative 80. So minus 80, right? I should say add millivolts on there, right? Which is equals to 0. Okay, that's 0. And this is B. Let's do C. Force equals negative 80 millivolts minus 100 millivolts equals 20. And that's C, millivolts. Did I not add millivolts on here? I thought I did. I'm losing it. Okay, let's do, I'm running out of space, so let's just do it over here. Force, we're doing A now. Negative 80 millivolts minus positive 40 equals negative 120 millivolts. So obviously that number is way bigger than everything else, right? So that's how A is the correct answer. Okay, based on the info above and nothing else, which ions are permeable at rest? Meaning which ions can flow in and out of the cell, right, at rest. So let's do A. Actually, well, let's do all of them together. So we are told that negative 80 millivolts is what we're trying to achieve, a resting memory potential. That's our goal, right? Which of these ions are contributing to that? Okay, what about A? A can contribute to it. Okay, even though it's positive 40, maybe some of it's permeable and some of like C is permeable, right? If you combine some of ion A and some of ion C, we could get up to negative 80 millivolts, right? Depending how permeable the ion is in the cell, right? Like for example, ion A can be very permeable, hardly any, but still permeable, and C could be permeable by a lot, right? So it's kind of like a tug of war game. That's how I like to look at this, right? Is that ion A and ion C, right, are kind of pulling, right, together. Let me draw you a picture. So say you have a tug of war match right here, right? So we have ion, ion C, which is -100, right? It has this rope here, right? And then ion A, let's do that in a different color. Ion A over here, it's +40. And we're trying to get, right, to like -80 here. So ion A is pulling some of it, and ion C could be pulling some of it, right, to get to -80, right? It could be some amount of number. So it's just like basically a tug of war match. However, notice that ion B is -80 millivolts. It's exactly the same as the resting membrane potential. So ion B could be contributing it, to it, and ion A and C could not be doing anything at all. We don't know, right? It could be either of those two scenarios. So the answer is, for all of them, is we can't tell. There's no possible way. Ion A could be contributing like this, scenario here, or ion B could be doing all the work of -80, because it's -80 millivolts, which is exactly the same as resting membrane potential, right? It's the same number. So for B, right, it is permeable. I mean, we don't know, right? We can't tell. But one instance it is, permeable, right? Or it can be, or it isn't permeable. In this scenario, ion B is nowhere to be found, right? I mean, it could very well be that it exists, at -80 millivolts, right? It could be like right here. We don't know, right? It is possible. It's a very high possibility, maybe not a really high possibility, but it's a possibility that it could be contributing, or it doesn't even have to contribute at all, right? This scenario is fine here too. So we can't tell. And C is the same thing as A, right? We can't tell. I know this one's a bit tricky. This is probably the hardest question on that midterm. Um, but yes, this is how it is solved. So hopefully this makes sense. If you don't understand it, I can explain in the comment section. All right. If we open all the channels, the C channels, so ion C channels, what happens to the membrane potential? Okay. So we were given that the membrane potential is -80, right? So we start at -80. And if we open all the channels, we want to get to -100. That is our goal, right? So our goal is to -100. That's what this is saying. If we open all the C channels, make them, everything is 100% permeable, right? So if it's 100% permeable, what's going to happen, right? It's going to go to -100 millivolts. C wants to get to that, right? So basically, think about like the tug of war scenario, right? But now ion C is giving it all of its power it can possibly can to get it to -100 millivolts. So what's going to happen to the membrane potential? So what depolarized means is the number gets higher, right? So for example, from -80, we go to, I don't know, say 20 millivolts. That's depolarization, right? We went higher. Okay, that's obviously not happening because we're going from -80, from it's a negative, to -100. We're getting lower, right? So that's not true. So it can't be that. No change. Well, that did not happen, right? We're changing. We're going to -100. Hyperpolarized means we're getting lower, right? The voltage is going lower, which we are, from -80 to -100. We're going lower. So this is true. We're hyperpolarizing. What's the net movement of C ions? Which way is it going? Okay, so first off is we're trying to get to -100 millivolts, right? So the ions need to be going into the cell. If we start at 80, and we're trying to get to 100, more of C ions will go into the cell to get it to 100. That's our goal. So it's an influx of ions. There's no net, it can't be no net movement because the number's changing, right? We're going to a -100. It can't be outwards, right? Because then this number of -80 would go higher if it was outwards. But we're not. It's an influx. We're trying to get to -100. That's our goal. And the way we do that is by C ions going inside because it's super negative. You kidnap a second alien with all the exact same properties and numbers. We insert a drug into its skin that blocks all of the C channels. The resting membrane potential remains at negative 80 millivolts. What can we conclude about the ion's permeability? Okay, so the first thing we can for sure say is that ion C, let me make that neater. I know my writing kind of sucks. I'm so sorry about that. I'll try to improve. Ion C, or C ion, has no effect. Because remember, if we started at negative 80 millivolts, then we block all C channels, C ion channels, right? Let me write C ion to make it better. C ion channels, and we still ended up at negative 80 millivolts. This means that C ions, the ion C has nothing to do with anything, right? It didn't do anything. If it's remained the same, then C ion didn't do anything. Okay. What about B ion? Well, remember how we said that B ion is negative 80 and resting membrane potential is negative 80? Well, we have to look at A and B together to answer this question. So B, let's do B. B ion is permeable. How do I know this? Well, I can tell you that A ion is not permeable or has no effect because, let me answer this one. So B ion is permeable because negative 80 millivolts, which is resting, equals negative 80 millivolts of the E ion of B. Okay, it is not A. A is not permeable because, remember we had this tug of war, right, scenario from before. If we have ion B here, which is, and then say ion A here. Okay, and then we're at, so this was negative 80 millivolts. This is positive 40. If they were both permeable, sorry, let me make that neater. Okay, if they were both permeable, the resting membrane potential will not be at negative 80. It would be somewhere halfway. Or it doesn't even have to be halfway. It could be here, it could be here, it can't be here, right? But it cannot be perfectly at negative 80 because A is contributing to something, right? So this must mean that A is not contributing at all. A ion has no effect. Because if it did, then the resting membrane potential would not be the same. But we stated the resting membrane potential remains the same at negative 80, right? So that's how you answer that. So this concludes the questions from membrane potential. Hopefully you found this helpful, and please like and subscribe. Here's what I'm planning to do, is when I actually start making, hopefully if I get enough subscribers and actually make money, what I'll do is when I start actually earning money from YouTube, if that ever happens, I'll give away the money. What I'll do is I'll create some scholarships, and I want to help you guys out. That's my goal. That's all I really want, is to help you guys out and actually go through college or whatever. So I'm planning, say if I somehow get $1,000, what I'll do is I'll probably make 10 $100 scholarships or something like that. I haven't decided yet, but I want to give it away, right? I'm okay. I don't really need it. I just want to give it to people who really need it. Actually, I want to put people through college and actually get a good education. That's really all I want. And I'll be very happy to show you how much money I make from YouTube if that ever happens. I'll make a video maybe once a month or whatever, and when I actually start making money, and I'll show you how much I make. because it's money's no object to me. I just want to give it away to people who really need it. All right, thank you.